Welcome back, folks, to Tenfold Live. You're watching a show that is proudly brought to you by Liberty. A very special shout out goes out to Liberty for giving us the opportunity to share all these awesome ideas with you. Remember, guys, if you know anyone who's not watching, please encourage them to also watch the program. And if you want to know how to basically build yourself up with the basics that could help you to understand what is going on here, provided you've got gaps from grade 10, 11, and 12, go to your app store and look for our app. We call it the Tenfold Education app. If you haven't downloaded it, it will also help you to send questions to us if you've got any problems on the topic that we're focusing on. On today's program, we're busy with statistics. We just looked at a question that was based on grouped data. Very beautiful question indeed. I hope you learned a lot from that. Now, the next question is one that is based on what we call bivariate data. The word bi means two, right? So what is going on there? We are basically comparing two sets of data, which means we're trying to figure out if the other one has an influence on the other one, right? Very important. For example, you could be doing a survey to figure out the amount of data spent by people versus the age of those people, right? Maybe you say an 18-year-old, how much data did they spend on the internet? And then a 20-year-old, and then 25-year-olds, and then 30s and then 50s. So that's you trying to compare the amount of data spent by people on the internet versus the age of these people. So clearly age is independent, but the amount of data that is spent is dependent. You guys at home who are watching the program right now, I know for a fact that you love the internet, and then you will obviously be spending more data because you are always on the internet doing important things, of course, such as watching the show on our app, because our app does also give you the opportunity to stream this show live. But anyway, let's get back to what is going on here. So in bivariate data, we're comparing two sets of data. We want to see if the other one influences the other one or it doesn't, right? Sometimes it does happen that there is no correlation. Correlation means like a connection or a relationship between them or an influence of some sort, right? That's what we're actually interested in measuring. Do they influence each other? Do they affect each other? Is there a relationship between these two variables? Is there a correlation? Right. So let's check the question that KG sent to us. It's a beautiful question that will help you to understand what is going on here. Right. So it reads as follows. It says here the math literacy teachers usually complain about their learners' language and reading skills. Apparently, one of the reasons why math lit is difficult is not because of the math, but the language that is used there sometimes is confusing. All right. And then it reads on and says the data below shows the percentage which 8 candidates obtained for English and mathematical literacy during the June exam. Right. If you think English affects the performance of learners, it makes sense that you might want to compare them. Take their marks of English versus their math literacy marks and see if there is any relationship. You might find that a child who's underperforming in English is also underperforming in math literacy. So that will then tell you that indeed English does have an effect or impact on the marks that learners are going to get in math lit. Just as easy as that. We are interested in studying that. We want to see that. That's what statisticians do. They take data and then we analyze it to try and make sense of whether there's a relationship going on there and if you can come up with interventions to solve a problem. So if this actually leads to a correlation, it means we need to do a whole lot of work on English to make sure that they understand how to work, how to understand English, so that when they do math lit, they're not actually affected that much. That's actually what is going on here. Right. So let's look at what is happening here. The first learner obtained 25% in math literacy, and they got 34 in English. The second learner got 38 in math literacy. They got 53 in English. The third learner got 40% in math literacy, and they got 62 in English. And then the data goes on and on until learner number 8, right? So those are the marks of each one of those learners. So this is learner number 1, this would be learner number 2, this would be learner number 3, 4, 5, 6, 7, up to learner number 8. So those are the marks that they're obtaining, right? Now, when I deal with bivariate data, this is the advice I'm going to give you, right? There's a lot of questions we're going to ask you. We're going to ask you to also put this information on a scatter plot and draw a line that you used to call the line of best fit. That line is also known as the line of least squares regression. So when you're drawing that line, right, we're going to need you to have the equation of that line. So here's my advice that works all the time. You will only get it here on Tenfold Life, right? You just go, take your calculator, and punch all this in, irrespective of what the questions are going to be asking you. Whenever you're dealing with bivariate data, take your calculator, insert all this information in your calculator, and ask your calculator to spit out 7 things. I call them the 7 parameters of regression. There are 7 things I want from this. Those things will help you to answer all questions related to this particular setup that we're trying to figure out here. Right. So I'm looking for 7 parameters of regression. Once you've got those 7 things, you'll see all the answers you need are exactly in those 7 things that you have calculated already, instead of working them out one by one. Right. So let's see what I'm talking about. I'm interested in, this is my advice, before you even go to start thinking about the questions. I almost wrote 7 wonders of trigonometry. Okay, cool. We're looking for 7 parameters. 7 parameters, right, of regression. These are 7 things that are going to assist you to analyze this data without any complication, right? So what are these 7 things that I'm looking for? I'm looking for something called an A value. I'm looking for the B value. I'm looking for something called the R, right, which is going to be what we call the correlation coefficient. And then I'm going to be looking for the mean of the X values. I'm also looking for the mean of the Y values. And I'm also going to be looking for the standard deviation. So I want the standard deviation of the X values, and I also want the standard deviation of the Y values. So those are the 7 things that I'm looking for. A, B, R, X bar, Y bar, standard deviation of the X values, standard deviation of the Y values. So remember, when I'm talking X in this case, right, when I'm talking X, I'm talking about the first thing that I have got on my table here, right? I've got math literacy, and I also have English. So normally, we want to see if English and mathematics during the junior exam, this is basically what you want to see. We want to see if there is any relationship between what is going on here. So the first set of numbers that we've got there would normally be what we put on the x-axis. So these would be what we put on the x-axis, and this would be what we put on the y-axis, right? So we want to see if there is anything that is happening in terms of the relationships between these two. We want to see if there's a relationship between math literacy marks as well as the marks that you have for what we call the English marks there, right? So let's see. So whenever I'm talking X, I'm talking math literacy, and when I'm talking Y, I'm talking English. Please keep that in mind, math literacy and English. So if you have what we have here, okay, so we're going to go to a calculator. Let's call our calculator, right? And then we're going to punch all those values and try to find all these things that I said we are looking for as far as this data is concerned, right? Okay, cool. So now, because we're dealing with bivariate data, we're going to have what we call the equation that is going to be a straight line, and the defining equation of that straight line looks as follows. It is y is a plus bx, right? This is basically what it looks like. So this equation of a straight line has an a value and a b value. That's why I've got a and b here as part of my 7 parameters of regression. Just take the concept from what I'm actually saying here. Very important. Now, what I'm going to do is I'm going to press the mode button, because that's what we always press when you want to analyze statistics. After that, I'm going to select stats, which is option 2. So you press 2. And then you will see there's a whole lot of options that are emerging there. The one that you used to work with was number 1, when you were looking for the standard deviation of normal data and when you are looking for the mean of the normal data. So I'm going to pick option 2 of a plus bx. You can see there, because I'm already seeing here there's going to be a linear relationship between the math literacy marks and the English marks. So I'm selecting option 2. Okay, so I'm going to press 2 for that. Now, after doing this, you'll see that your calculator gives you 2 columns, column for X and column for Y. So for X, we're going to put all the math literacy marks, and for Y, we're going to put for the English marks here, right? So let's see what will happen. So first thing, my maths literacy first mark is 25, so you type 25. My second mark is 38, so I'm going to type 38. My third mark is 40, so I'm going to type 40. My next mark is 47, you put 47 there. And then you're going to have 12. This child got 12, terrible mark. Please don't get these kinds of marks. The next child got 49. And then the next child got 54 for maths literacy. And the last child got 59 for maths literacy. You'll see the calculator just put zeros for Y. So you need to press the right-hand side arrow, and then you go up, 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 up until you get to the first value there, which is going to be related to 25, that matches 25. So the English marks, 1 mark for English is apparently 34, and the second mark for English is 53, right? And the next mark is 62, right? And then the next mark is 44, and then the next mark is 20, and then the next mark is 50 for English. And the next child who got 54 for maths literacy, this child got 61 for English. And then the last child who got 59 for maths literacy got 54 for English, right? You insert your values in your calculator. Very nice, no complications there. Once you're done, then you press the AC button, right? Now, if you look at your calculator, you will see that by the button 1, there's stats, which is written in yellow, next to that button 1, right? So if you want to access anything that is appearing in yellow in your calculator, you need to push the shift button first. So I'm going to push shift, and then I'm going to go to 1 and push for stats. So a lot of things emerge there. The one that I'm interested in is number 5. I want all the regression parameters, that REG. So I select 5. After that, there's A, there's B, and there's R. So I'll press 1 for A and press equal to. The calculator says A is 16,89 to 2 decimal places. So 16,89, right. Then I'm going to go back. I want B now. It's shift stats by 1, and then you select regression, and then you select B, which is option 2. You press your equality sign. I'm getting 0,75. So 0.75. And then we want R. So I'm going to go shift, and I'm going to go stats, regression, option 5. And then R is option 3. And then you press the equal to, you get 0,82. So we're getting 0,82. So 0,82. Beautiful stuff, right? So we've got A, we've got B, and we've got all the things that we've been looking for as far as A, B, and R is concerned. There's B still 0,75, right? Once you're done with that, we also said we are interested in the standard deviations and the means. So what we're simply going to do here quickly, we're going to go back and say shift and then press 1. Now, we're no longer going to REG, we're going to variance, VAR, which is option 4. That's where you're going to get your mean, your variance and standard deviation from. So I press 4, and you will see that X bar is number 2, and Y bar is number 5. So option 2, equality sign 40.5. So this is 40,5. And then I'm going to go back for the Y ones, shift, stats, variance, option 5, equal to, gives you 47.25. So 47,25. Collect these things. It takes about 5 minutes to get all this done, but you have answered all the questions anybody can ever ask you on this information. Shift, stats, var. I'm now looking for the standard deviation. That's option 3 and option 6. So option 3 for x's, we're getting 14.57. So 14.57. And then the standard deviation for the y values, shift, stats, var, option 6 is the one we're looking for. And then if you press the equality sign, you get 13.33. So 13,33. So this is essentially what I have. Anyone who asks me about the standard deviations, I already have that. I don't have to go back to my calculator. I already calculated all those things that anybody can ever ask me to figure out. So these are the 7 important things that you need from questions that deal with grouped data. Now let's go to the questions, and you'll see we already have all the answers they're asking. Right. The first question that KG wanted us to look at is asking us to calculate the mean percentage of the mass literacy marks. Mean percentage of mass literacy. My mass literacy is X. So the answer to that first question, the mean for the mass literacy, come check here. The mean for the mass literacy, answer number 1, the mean of mass lit is simply this number here, right? So it's going to be 40,5. That's the first answer to that first question. Right, number 2, they're asking us for the standard deviation of the mass literacy marks. Standard deviation of mass literacy, remember, I said my mass lit is always going to be X. I put my mass lit as X. So that's basically going to be 14,57. That will be the standard deviation of the mass literacy marks. And then the next question they say to us, we need to determine the number of learners whose percentages in mass literacy lie within 1 standard deviation of the mean. So 1 standard deviation of the mean. If you know the normal distribution curve, you should know that we won't struggle to find this, because what you're simply going to have is, if you've got this kind of a setup, this is the normal distribution curve. Here, right, and here would be 1 standard deviation, because here in the middle, you will have your mean. And then on the right-hand side of the mean, you're going to have X bar plus 1 standard deviation, and then X bar minus 1 standard deviation. So we are interested in figuring out how many numbers are within here. They said within. How many marks lie within 1 standard deviation, right? So those will be the numbers between X bar minus mean and X bar plus the mean. So go back to your calculator, try to figure out what is X bar, 40.5, right? minus 14.57, I'm getting a value of 25.93. So this is 25.93. And those that are above 1 standard deviation from the mean, right, it's just going to be the same numbers, but you're not subtracting them now, you are adding. And then you're going to have 55.07, so 55.07. So I'm looking for all the marks that are between 25 and 55, right? So which marks are those? Let's look for any mark that is more than 25.93, but less than 55. So if you go back there, it must be more than 25. This mark is less than, so we're not counting this, it's outside. 38 is within the range that we're interested in. This is within the range. 40 is within range, within range, within range. 12 is not. 12 is not because it's smaller. Remember, we want between 25 and 55. So this will work. 54 will also work. 59 is out. So we've got 1, 2, 3, 4, 5 marks in total. 5 marks lie within. They are between those two numbers that we discussed here. So those are going to be your answers. So basically what you simply have here is a situation of saying we've got 5 learners. 5 learners have marks that lie within 1 standard deviation from the mean. Beautiful stuff. And then the next question says we need to use a graph paper to draw the scatter plot for this particular data. Okay, we won't have time for drawing the scatter plot of this because we literally left with like a minute, right? But what I can show you is the next 2 questions that the examiner is asking you here. They're asking us to find the equation of least squares regression. They're also asking us to work out the correlation coefficient, right? So if you go back to the 7 parameters, the things that we've calculated, when we start asking you for the equation of least squares regression, we're asking you for something that is known as y is a plus bx. Your a value is 16.89, and this has to be added with your b, which is 0.75 with x. So this will be the equation of least squares regression. When they ask you for the correlation coefficient, this is your correlation coefficient. So your R will be 0.82. That will be your correlation coefficient. And remember, the correlation coefficient always lies between -1 and +1, right? So you can tell the strength of the relationship between those two variables you're plotting by checking the value of your R. Now, since R is 0.8, which is very close to perfect positive correlation, we know that there is in fact an influence between these two. The correlation here tells us that there is actually a very strong positive correlation that exists between mathematical literacy marks and the English marks. So it does in fact prove whatever the suspicions that the math literacy teachers had about the influence of the particular English mark versus the math literacy marks. So somebody's probably wondering, why would you ever need the X bars and the Y bars? Well, just in closing, the X bar and the Y bar are normally what you use after you've done your scatter plot. So you would have your scatter plot and you will basically be plotting your points according to what will be happening. This is what will be happening. And then after that, you can then be able to draw the line of best fit. When you're drawing the line of best fit, according to what I see from my equation, it's going to have a y-intercept of 16.89. So it's going to cut my y-intercept at 16.89. And when I plot that, I need to make sure the line passes through where X bar meets with Y bar. And then when you join them, then you're going to get a nice line, which is called the line of least squares regression, what you people used to call the line of best fit. Beautiful question indeed. It's just that we didn't have time to go much more deeper in terms of plotting on the graph paper, but I think you've got a general idea of what is going on when it comes to this.